Okay. Good afternoon, and welcome to my session. Today, we're going to try to deal with historical data, which we accumulate in the databases. This session is actually a second one after the session that I did a few years ago, partitioning, do's and don'ts. And after that session, I received many questions on how to do partitioning actually in the database and how to deal with the big data in the database actually, relational big data. And I got several customers with their specifics, and we implemented partitioning many times along with the different other optimization techniques in the database. So I think this is a time to offer you some options for keeping the data in the database, but trying to deal with them from different perspectives. So I'm Maggie. I'm a CEO of two data platform companies, one of which works in Sofia, where I come from, Bulgaria. And the other company is working in Oslo, where I live, actually. I live in Norway, which makes me probably one of a few who don't complain about the weather here. So I'm Microsoft Certified Master, MVP for 12 years, I think. I don't count them anymore. I just love talking, and they keep me promoted. So, and I'm on MCT as well. And for today's session, I'm going to use one of my customers' cases, not because it's the most interesting one, but because it's probably the most challenging one. So it's about building a data management strategy, which is basically how to deal with the big amounts of data in the operational database. And it's about emergency services. So this application is actually covering some very important functionality, very critical functionality of emergency control rooms. So all those operators who pick the emergency phone number, and they have to deal with many things, and their application should be very fast, actually. So this means they need to register an incident. They need to try to get as much information from the caller as possible. They need to be able to make a really fast decisions on sending an ambulance, for example, or a helicopter, or like building a mission to help a patient. So in that case, the performance is exceptionally critical. So we have this case, and of course there are a lot of specifics. There are very much a complexity in the database. So I'm not just covering that because I'm still working with a customer, but I'm using just a few tables out of that particular schema in a version that is not currently updated, like the one that we work with. But that, I think it's good for a specific example here in this session. So think about it as incident, which is basically what it's all about, registering an incident. Think about the table, which is patient. So we have patient, and here, it took me a while to understand that, by the way, but thanks God, it's good developers to argue with you sometimes, so you got into the subject area. So in this particular case, the patient is not the reference table. The patient is actually the table which is part of like part of the relationship of one to many. So, and the first thing that I tell them is like, you guys, you need to fix your relationships. And yeah, of course, this was not the correct case because the relationships they had was really good in that particular example. So we register an incident, and basically the operators need to be able to register an incident no matter how many patients and no matter what kind of like data they have about the patient. So those data about the patients, they can come later, they can fill them up later. It's like if you make an analogy with AdventureWorks, then we have order and order details. Now we have incident and patients. So, of course, there are some important results out of that, but that's probably another presentation only about designing a relational database, so I'm not getting there. Anyway, my first, that's a very important in the requirements, store data forever, no deletion. No usage of the data should be presented in the database forever. And then they need to be able to edit records back in time, anytime. And of course, performance related. So the first thing that I asked them was, okay guys, let me know how do you use data. So, and we have active data. Those are active incidents that they could potentially edit on the first 24 hours. So basically, the most changes happen in the first 6 hours, and they expect the incident to get in the status closed after the 6th hour. But it could get like up to 24 hours, because once the patient is in the hospital, let's say, or emergency, then the control room is basically finished their job. So then we have a closed incident, and the closed incident can be potentially updated with some new data about it within 3 weeks from its creation. And then we have closed, seldom reopening incidents, read-only with seldom updates, and potentially data which will keep forever. So it looks like a sliding window scenario for me. Or to me, it looks like really strictly or very good split that we have between the intervals of time. What about the data volume? So it of course depends on the schema, and it's basically evolving. The project is not finished yet, but we dealt with the reference tables, which are like no worries about them at all. And then we have these operational tables, which could grow up between 1 and 20 million per year. And if you think about forever, that means a lot of records, right? So logging tables, of course, this kind of application, they need an intensive logging process, from tracking the record development to potentially logging every single action that the user performs, in order to get the history about that after a while. So we expect to have like more than 50 million rows per year for some of the logging tables. And what I did was like, yeah, we have a very kind of like obvious solution. Let's partition, guys. And they were very happy hearing that, because their first idea was to potentially try to delete data from the operational database, which, considering all the dependencies an incident has, it's not an easy task. And they need to keep the locking behavior during the deletion in order to not lock escalate during that process. So they embrace the solution. And how many of you actually have an experience with partitioning, table partitioning? Oh, almost half of you. That's good. So when we do partitioning, then this means we split data in chunks, right, based on the criteria. So a criteria is usually a column. And we define for that a partition function, which SQL Server uses against the record that is coming and that particular value of the column. And based on the partition function, it returns the partition ID, which, on the other hand, helps the query optimizer, the query processor, to place or access the row in a specific physical partition. So, in other words, if I think about like splitting the partitions by date, then I would be able potentially to define or to align with the sliding window scenario, and to build a partition based on that criteria. Well, it looked to me, at least in the very beginning, that this was the right solution. Well, what if we select some data? Oops, sorry. What if we select some data and we say, okay, so from where clause of the select statement should potentially tell the date of the incident, and then based on the date of the incident, we will be able, or query processor will be able to identify the partition ID and force the query to run and to access the data in a specific partition. So in that particular example, that means we will be able to deal with the most recent data, and the other part of the data will be available for a potential different kind of querying. So by doing that, I will be able to avoid the escalation of potential queries that run over the historical data. So based on that, I define very important rules for partitioning. So obviously, partitioning will work or tend to work very well when we have a sliding window scenario, which means, in this example, filtering by date. So that means, in practical T-SQL, that every where clause that a query has, every single query has in this database or runs in this database should contain the partitioning key, meaning an incident date, including tables that we join. So that means every single table, right? Otherwise, we will not be able to identify the partition, and we will potentially run a query over the entire stuff, which is a huge problem, let's say. So when partitioning a cluster index, the clustering key must contain the partitioning column. Why? Because actually the clustering key rules where the data chunk will be stored physically, where the rows will be stored physically. So if I have this partitioning as part of my clustering key, then I will be able to force specific records within that particular year. If I think about the early partitioning, then I will be able to force those records to be stored in one single partition. So another important thing, very critical, the main goal here is to achieve the partition elimination, right? So that we work within a single partition. That could be like a year, but that could be 3 months as well, or even a shorter period of time. So in that case, if we must guarantee a partition elimination, then the partition key must be the leading column of the index. That's a very important requirement, guys. So do I have other options? Yes, I do have other options. I can partition by one key, but organize, let's say, a cluster index by a different column. Well, I tried that, and I will probably be able to show you that as well. But that didn't actually end up really well in every single query that I tested. So I wouldn't go there. If I really need to partition, then, and I really need to achieve the partition elimination, I mean, from the logical reads perspective, then I will go with that case. So what does it mean for developers? That means they will need to align with all those requirements, and I need to change the primary and foreign key constraints because I need to include the date of the incident as part of the cluster index key or primary key, and it should be on top of that a leading column of my index. So if I need to join tables, then I need to use the common partition function and schema for tables that I tend to join. So based on that, let me switch to the demo and show you some examples. So what I did here, yeah, you will probably need to zoom it out a bit, zoom it in. Yeah, okay, good. So, yep. So I did partition incident and patient table, and I managed to load and test with around 3 to 4 millions of rows, between 3 and 4 millions. And I partitioned on incident date created, and my primary key, which is my cluster index as well, in this case, is on incident date created with the leading column and the real primary key of the table. I'm not saying that this is best. We find out that we could do more on that part, but that's yet another story of, again, relational database design. So this is the partition function that I've created. It defines the ranges of data. And then I have a partition schema primary for the testing purposes. And then I created a table incident here. Not going to every single column here, but what you can see is that I have a lot of var character columns. And even, in the current edition of the schema, they added even more. And then I'm defining the primary key cluster, and I'm saying that the leading column of the index is incident date created, and I'm including incident database ID as well, which is basically the ID of the incident, and I'm forcing that to be created in that schema in this case. So what I got here is like, yeah, this is my incident primary, this is my date created, which is the leading column, and the partition key. And then I have this interval, and then I have those boundary values, and the rows are split differently between partition, which is generally not a problem at all. It really depends on the queries that I'm sending to the database. And then I'm doing the same with the patient table. Again, remember that this is not a reference table. This is basically many in the relationship incident to patient. And we have even more var character columns. So why I'm mentioning that? Because this is important when you decide what to do and how to deal with a big amount of data that you accumulate in the database. The size of the record matters in this case. It's not just about the number of rows, it's about the size of the record as well. So, yeah. Yes, exactly. And especially if you use Unicode, because we need to do that, then it doubles the size of the table. So based on that, we need to define a composite foreign key, which make the developers feel a little bit like, I'm not sure, so we probably need to do some changes in the schema. Yes, guys, you really do need to do some changes, I'm afraid. So, and then after doing that, you can see how a query like this looks like. So I'm using the star, and I will be using the star during my demo. Why? Because the developers actually use Entity Framework. And you can imagine how the queries look like. So it's like, especially when they join, you feel like when you see the query, you feel like they actually get the half of the database. So the field list is really broad in this case. So I have this query, which is a cluster index seek, but basically what happens here is I have a partitioned column and that partition table, and now I managed to achieve the partition elimination, right? Because of the where clause that I have. If I compare this query with the non-partition table, which is like just incident one, I'm not really creative on naming, as you may see. So if I run that comparison, then you can see that basically the partitioned query runs way faster and has a better plan than a same query against the non-partition table. What's the case here? It's about the star. Right? It's about the select list, because if you run with a really broad select list, there is no non-cluster index which you could create on the non-partition tables, which could optimize the stuff. So even if I add the filters, I'm still on the safe side, which is fine, because I still have partition elimination here. And that is still not a good option for a non-partition table. What about the joins then? Well, if I put a where clause on both tables that I'm joining here, then I will be sure that I still achieve a partition elimination so that Query Optimizer could potentially focus on a specific partition from both tables and it could join a less amount of data, right? But again, this is something that they must do. So here we go. It works separately on every table. It gets the data from every table, and it then joins the data by using a hash operation. Yes, if I increase the interval, then I will need more memory, probably, for the hash operation. But still, I could do that, and I'm not basically assuming at that point of time when I create that, I haven't assumed that there will be something which could run over the entire data set. Well, for me, during those tests, it seems that it worked. And what about comparing a different partition key? So I mentioned that there is an option for us to potentially create a partitioning on date, but to define a cluster index on a different column. So in this case, I'm defining a cluster index. This is a different database and different table in that database. And this table is partitioned by date, but the cluster index is by incident ID. Well, in that case, you can see that this query is way more expensive. So why? And even in that case, I have like an index scan operation. On top of that, I'm still able to perform partition elimination. So it definitely uses one single partition. But actually, the cluster index is based on an ID. So it performs a full scan of the cluster index, even though it manages to perform a partition elimination. That's why it's not really good idea to have like a leading key and partitioning key different than your cluster index key. So, well, that could be my potential design end. Well, when I presented that to the developers, they say, no. Why? Well, because we actually cannot say that our query could have a where clause, that where clause for an incident. But you just told me that you have this sliding window scenario. Well, yeah, for some of the operations. What? So, okay, now let's give me an example of what kind of operations or what kind of queries go out of that scope. Well, we need to find all the incidents for a particular operation room or control room. We need to find all the active incidents, and we need to find if a patient was participating in an incident at all, without date, I mean. And I'm saying, are you actually saying that in that, like, 2 million per year table, you are going to do a select distinct over a name column? No. So, and in that case, I actually started thinking, well, what about the sliding window? It was just for updates. So we don't know everything about the queries in this particular solution. And we started diving into querying and how the developers actually send queries to the database. And yeah, if I have partitioning, if I have my table partitioned and I run a query like this, then you can see that, yeah, what I'm doing here is like I'm touching all the partitions. And not surprisingly, I don't have a filter over my date, right? So what if I compare with sorry about that. I don't know what, yeah, my mouse is going somewhere. Okay. So what if I compare with non-partitioned? Well, with the non-partitioned, it could be, yeah, that's partitioned, sorry. But if I create an index on the non-partitioned, and let me do that. That will be challenging. Okay. And then let me compare. Okay. yeah, then you can see that potentially my partitioning query is more expensive than the query that I run over a single table. If I do something with the indexing and like have a smaller list of columns in the field list, then I could do better with a non-partition table. So how could we optimize the partitioning for those cases? Well, we could. We have two options. We can add more indexes, like aligned and non-aligned index. So aligned index means an index which is partitioned over an existing table. So aligned index on my control room will look like this. So I have my aligned index on AMK ID, and I'm creating it on the partitioning schema. So by default, SQL Server will add my partitioning key to that index, but the leading column of the index will be AMK. So if I run this, then I will be able to have to search for AMK ID and still potentially hope that it will perform a partition elimination for me. Well, not exactly, but at least I could do better with the AMK when it comes to logical reads. So my index will look like this. Will it be the same as incident date created, AMD, if I put the date created first? Well, it will be similar, but I don't see any usage of this one because actually what I need is AMK, right? So I do have incident date created already. And then I am saying, okay, let me create a non-aligned index. A non-aligned index is a single B-tree structure comparing to a line index, which is basically a B-tree structure in every partition that I have. So when it comes to partition elimination, there are two stages that SQL Server performs. The first stage is try to identify per searched values the partition ID. And then it performs the second stage, which is called the skip scan, which basically tries to get the data what I need. In this case, when it comes to the first index, I will have this as a feature of my aligned index, but on the second case, I'm not having that. And if I compare the indexes in this case, then you can see how they are different from the index physical stats. So the first index is just one single structure. This is my first index. And the second index has a leaf level and non-leaf level for every single partition. You can see that by partition number. Basically, the amount of data pages is similar. The record size is also similar in this case, but I have two different kind of structures. And with a non-aligned index, I don't have the partition key included automatically as an index key, right? Good. So let's test that. Well, what query optimizer will choose in this case? And let me first compare those two, and then by having the execution plan, whoops, well, they are basically the same. So you can see that they are the same. The only difference is probably the scan count. This is because of the partitions that it manages to scan. Why is that? Well, in this particular case, I have many records, and the AMK ID is not that selective, or is not selective enough, on top of my on top of my field list. So those two combinations are something that puts the query optimizer under the question which one to choose. Well, it chooses actually in this particular case because it will perform a scan anyway and it will cover all the partitions. So it chooses to use aligned index. In other words, if we have a large column list and low selectivity, then scanning anyway will happen. So both could work, but aligned index will potentially perform better. On the other hand, the column list also matters. So as I mentioned, when it comes to the column list, then this is something that we need to consider. Well, you can see that it's still, in that case, it chooses non-aligned index, but they are very, very similar in that direction. Well, when it comes to a very unique column though, like for example, a last name column, and the table which is way bigger than my first one, that's a patient table, then the things are a little bit different. So when it comes to that particular case, I could optimize by potentially having a non-aligned index. Or the optimization path in this case, is probably a non-aligned index. Good. Here we go. So a line index is slightly more expensive, and that's because a non-aligned index is very selective, right? So it will manage potentially to isolate, or it hopes to do so, to isolate a specific records and to potentially find the results in a specific partition. So more unique the filter is, non-aligned index is better. What about the incident status? It looks like a filter index to me, which means it's very selective. So if I create a non-aligned index on a filtered non-aligned index, that could cover my incident's state as well. What about joins then? That's a little bit more complicated. So we can think about joins as a way to like debate. It so much depends, guys. So we can think about join as covering with the non-aligned indexes. That's the first case. But that will be the case when we can potentially say, okay, if we have a limited set of columns, then we could cover joins per table with the non-aligned indexes. Okay? Well, on the other hand, if we manage basically to do the where clauses in the correct way, then we will be able to perform a partition elimination, and align indexes will be useful. Well, according to joins, there are some specifics. What about if I run a join which is, let me drop that. What about collocated join? Have you heard about a collocated join in the partitioning? No? Okay, that's something that Query Optimizer performs in a specific occasions, which means trying to join partition by partition on pairs, right? So imagine that we have an incident and we have patient per year, and then we join one after another, but that means the Query Optimizer is able to isolate and pair them and collocate them so that it doesn't actually joins every single partition with the partition of the other table, but it manages to perform that faster and better with less memory. So how that works? Well, if we think about a collocated join, then if we think about how that works in the perspective of Query Optimizer, then think about the join column. Well, if it's about dates, that will not work at all. But if it's about a column which we use for join, then we could potentially join two tables based on an incident ID. And then all those incident ID could be in the same partition. That means we don't partition by date, we partition by incident ID. If we partition by incident ID, then it's very likely to end up with the same incidents in the same partition. And if we manage to define the intervals of incidents, then we will get together, like we will move together all the partitions, and we will be able to achieve a collocated join. Well, that sounds very optimistic, but it's basically doable if you have a short field list in your joins. Then in this case, we define a non-aligned index on a different partition schema in the same database. And then we could have non-aligned indexes of both tables partitioned by incident ID instead of columns. And then if we manage to collect all the columns in the non-cluster index, then we will be able to potentially do a lot of stuff in that case. Well, yeah, that could work, but it really depends. So with those broad queries, though, probably not. So with what discoveries did we make during the testing and during that scenario? So first of all, we have many queries, at least a few examples or cases when we don't actually select by ear. We basically select or do a lot more than that. And queries are broad. It's entity framework style. So all those optimizations that I mentioned are about non-cluster indexes, right? And non-cluster indexes depends on the field list. If you don't manage to cover the field list, then, and the selection is not filtered well, then you basically don't use a lot of the benefits of a non-cluster index. So, and of course, challenging conjoins. What else could we use in that case? Well, I'm not saying that we don't use partitioning. I'm saying that we need to question that solution for operational databases because there is a high risk of hitting the scans of all the partitions if we don't know all of our queries. And trying to troubleshoot and cover with the non-aligned indexes later is not the best solution at all. It could work for some cases if you have existing partitioning, but for something that you design as a new solution, it's probably not a good idea to just rely on that. Then what we could consider is filter indexes and operational analytics. What about column store indexes? Well, it depends. We have this operational analytics, which is like warm data covered by column store index, which is filtered index, by the way, and hot data covered by traditional row store indexes. What about we do something like this with our existing incidents and patients? Well, if I do that based on the time, then I will potentially have all the old records covered in a column store index and all existing, like, for example, the recent records covered by a row store index. That could work for some occasions, but I cannot move the filter, right? So I create a filter by date, but I cannot move it. So the syntax of this, I'm not running that now because it will take a while, but I'm going to show you just the syntax of it. And here we go. So if I create a non-cluster index, and the non-cluster index has a where clause, or non-cluster column store index, I mean, then I can include just the specific columns, and I can say, okay, all of those could be just an old record, and my existing records could work for a particular, like, active period of days. That could be a case, but the problem with that is that this is not changeable, right? So how am I going to deal with that? Am I going to rebuild a cluster index? Nah, that's not going to happen in our operational database, right? So, and on top of that, it will cover that, but if I hit, like in my where clause, more like a broader interval, then I will do a scanning of the entire table. And that's because my column store indexes cover, filter indexes cover just that part. So I need to build another index which covers the most recent data so that I'm splitting data in two different indexes, and Query Optimizer can work with both of them, like combining them in a single query. Well, obviously, that solution will not be the best one either, because what I have is like specifics on the filtering, and on top of that, actually the good thing is that I can update some stuff, like updatable, this index is updatable, non-clustered COMSOR index, which is good. So what about creating that index on status, incident state? Will that work? Well, incident state is not updatable, right? So I have active and potentially closed incidents. So I could create a column store index which could cover my closed incidents, right? And then I could have my index, well, kind of like non-cluster index, basically, which covers the columns that I need for active instance. Well, that could work. The problem with that is, again, the long field list in the queries. So my non-cluster index row-based will not be able to cover everything they send from entity framework. So in that case, yeah, we need to make some deals with the developers, either to make changes which they refuse to make, or we do what? So basically, some changes we must do, obviously, in order to get to the same page at the end. So it's good that we have this option, but this option is basically, again, have something to do with the entity framework queries. What about partitioning and non-cluster COMSOR index? They could work together as soon as I have a non-cluster COMSOR index which is filtered. Well, fine, it could be aligned or non-aligned as well, but that also could be something considering partitioning. And when it comes to partitioning, and when it comes to non-aligned indexes, and we have all those throwbacks that I mentioned. Should we consider multi-table solutions? Yeah, could be. Could be better, at least. What about partitioning switching out? Well, that could work. Basically, if I partition operational tables, and then I do like switch out, for example, incidents based on date or based on the ID, if I partition by ID, right? Then I could switch those to archive tables, which could also be partitioned. This is a very simple operation, like this. This is instantaneous. The problem with that is that no non-aligned indexes are possible. So non-aligned index could not work with partition switch out. They cannot work together. And on top of that, if this is about referencing tables like incident and patients, I cannot have a foreign key constraints either, which again is a conflict with the schema and the developers in that case. What about getting back to the deletions? So, well, yeah, that could be a simple solution for this case, but that simple solution will need to be like aligned with all the stuff here that we have. It's not a simple one to develop because of the dependencies, but it's doable, and it could work if we get those archive tables in the database. And those archive tables, by the way, could be partitioned, so we can gain benefit of all that, like column store covered with a where clause, over partitioning, and have everything which could optimize the partitioning and get the fast queries on archive tables as well. On top of that, we could, of course, use read-only replicas to force those kind of queries, or do some other stuff of optimizations on archive tables as soon as they are like separate tables from operational. The point is, to get the operational tables as small as possible, because yeah, for now, we didn't make a deal. We didn't end up with a deal of how much changes they need to make in the database and what kind of changes we need to align or to keep for keeping the history data. So there is no final solution yet. We keep testing different options, but this is just an ideas and benefits and drawbacks of every single one of them, so that you can think of how to use that for your specific queries. Oops, yeah. So the main problem that we find is that entity framework is like, it's not a good advice that we have. Like, the queries that they produce is so difficult to optimize and to get a solution for them. That's why deletion for now is like a favorite solution, because otherwise, like, all the development team should go and align with some of the restrictions that we have, either with the partitioning or with the column store index. So, but I didn't give up yet. I haven't given up yet. So I don't know if any of you have managed to change how the developers work, like from code first to database first approach. So they're about to do some stuff as well. At least the normalization and all those envar character columns, we tend to like split them in the different tables. We think about like optimizing that stuff. But from the historical database perspective or historical data perspective, it's not an easy solution. Anyway, if you tend or think about implementing partitioning on operational tables, I would be very careful with that solution. I would rather do partitioning on archival tables. There is no single solution, though, for all tables. But what we need to know is, like, what queries do we have? So in order to go with the partitioning or the column store index, so the column store index is a bit easier in that direction. But if you plan to partition, then you really need to know every single query that you sent in the database. So that's a very important stuff. Every single case that may have, like, be critical and may have to be covered in the database in order to not be surprised later on. A very good option for partitioning is all those logging tables, because they don't have like connections, they don't have relationships basically in the database. They tend to like grow, they don't have updates. They only have inserts, and that works for many of our customers, basically. So if we have something like this, with just only inserts, then that could work with the partitioning really well. But if we have like tables which are related, which are operational, which have like deletes, probably not deletes, but updates, then I will be very careful with that. Good. So any questions? Well, yeah, of course. What isolation level you mean?
Or how are you testing this? Because computer performance per se is you will have a lot of concurrency.
Yeah. So now we plan. Okay, I got it. So what about the isolation level and concurrency during the testing? Well, the good point is that we don't have that application in the production yet. So now they build a testing application, like for the specific testing environment, in order to generate the data and in order to generate more like real type of data, let's say, in a test environment, so that we manage to test all the stuff. Because now we just test in separate servers, which is completely disconnected from the application, because the application was in the development phase, right? So, and the data that I've generated, I use RedGate generator, so for that. And when I use RedGate generator, I cannot specify some stuff. Like, for example, incident ID should be increasing along with the date, so that I have a good statistics on like dependencies between columns and correlation between columns, so I can be more specific in troubleshooting and tuning some stuff, and I can see the execution plan, and I can see every single case. But we're planning to do so, and the test in the scripts already, so that you can see that in the testing environment with more data and more real type of data. Good question. Yeah? More questions? No? Okay then. So if you still have some questions, you can email me. Yeah, thank you for attending this session, and have a great event